Hello, we're going to do two things now. First of all, we're going to analyze a hydrograph. And remember that a hydrograph is the response of the watershed to a rain event. So what we're measuring is the direct runoff from the watershed, the outlet from the watershed, not the storm itself, but the response to that storm. And what we're measuring is surface runoff. And the direct runoff needs to be subtracted from the total runoff, which includes the base flow. So the total runoff minus estimated runoff is what gives you the direct runoff. Now, you do not always have that information of the estimated base flow. So sometimes you'll have to estimate. And we're going to talk about two methods to estimate that. The first one, you go from the point of the rising limb. So here you have this point going down and then starts going up. From the point of the rising limb, you will move horizontally to this point, which should be the point of greatest curvature. So then this would be your base flow that you subtract to obtain the direct runoff. Now, let me talk here for a moment. How would you calculate that? So you would have, if you don't have the equation, you have here a value of delta t, right? And it's like doing integration. So you have values of delta t. So you will have a summation of delta t times q. So for each one of those delta t's, so the summation of those values will give you the volume, the total volume. But remember that in hydrology, we talk about depth of the storm. So if you have that volume of the runoff, because that's the volume of the runoff, and you divide it by the area of the watershed, it'll give you a depth. So for a particular storm event, you calculate this area under the hydrograph after you have subtracted the base flow. You can calculate the volume of the runoff, and if you divide by the area of the watershed, then you have the depth. So that's for that specific storm. Okay, so that's the first method. And then the second method, you have to look at the point before the rising limb. Let me erase this for now. So what you look is at the point before the rising limb. So this is the point, and you will go tangent there until you have, this is the center line, the peak. You go here and you have that first point. Then you will move to the right n days, and this is calculated by having n in days. Area is the area of the watershed in square kilometers. So you will move to the right in days. Now you have to be aware that you need to look at what is your time axis here, and you need to convert that to days. And so you move to the right n days, and then that intersection. So now this would be the base flow. Okay, so again, you have to calculate the volume of runoff in the same way. You have here your delta t and your q, so you have to do sort of an integration, but then the volume would be the same, right? You have the summation of your delta t's times q for that. Okay, this is the volume, and the volume divided by the area, and you need to be aware of the units. Okay, so if I have the volume in cubic meters, then the area is in square meters, so this is in meters, but we usually, if it's the metric, we express it in centimeters. If it's in US customer units, then it would be in inches. Okay, so one of those two. So in this problem, you will have to calculate the base flow. So using those two methods, what I want you to do is to pause this video and then work on this. You have to turn in one per group. Now we will look at the unit hydrograph. A unit hydrograph is a hydrograph that results in a runoff of 1 inch if you're in the US customary system, or 1 centimeter if it's in the metric system. So whenever we looked at this problem here, we calculated a volume and a depth of a rainstorm for that particular storm event, and now we're going to build upon that same hydrograph to convert it and have a unit hydrograph. So this kind of becomes almost like a fingerprint of the results or how the watershed responds to a rainstorm of a specific duration. But now, instead of having 2 or 3 inches, whatever depth you had for that particular storm, we will turn it into a storm that has 1 inch. So that means that when I have the unit hydrograph, and if I calculate the same, using the same procedure to calculate the total volume, so I have the summation of the delta Ti times the Qi for each particular, I will get a volume, and then that volume divided by the area, what I will get is either 1 inch if I'm in the US customary, or 1 centimeter if it's metric. So that's your check for the unit hydrograph. But then it will have a very similar shape to the original storm that has or does not have 1 inch or 1 centimeter. Okay? So we saw how we calculate the volume. Why a unit hydrograph? Well, this is super important concept because once you have the unit hydrograph for that watershed, you can calculate runoff for any other storm. You can estimate that total runoff. Now, we will not look at that this week or next week. We'll look at that when I return, but it's important that you start developing those skills. So here you have the recorded discharge, and then this is the unit hydrograph. Okay, so for the unit hydrograph, you have to subtract the base flow, and then this here has a very similar shape to the original. So it's almost like a fingerprint, as I mentioned earlier. So let me do this as an example of what you need to do. So this here is information that's given, and then you have the stream flow that's given, the watershed area, of course, it's given, and in this case you don't have to estimate the flow. If the flow is not given, you have to estimate it. And then you have the direct runoff that you calculated by subtracting the stream flow minus the base flow. So stream flow minus the base flow. So this here is stream flow minus the base flow. Okay? And then the direct runoff, you have cubic meters. How did you get that? Well, the direct runoff would be and this is in cubic meters, would be cubic meters over second, which is the direct runoff that you had here, right? And then you have your interval, in this case is 6 hours, right? And then you need to do the conversion, 3,600 seconds per hour. So this is your delta T. So you need to be very careful with the units. Okay, so you do that for everything, and then here you have the summation. So here you have the summation of the direct runoff, and this is in cubic meters. Okay, so this is the total volume of the runoff, what we saw earlier. Then now, as you divide the direct runoff by the watershed area, okay, then you will get, in this case, 3.99. And make sure, if you want to pause this and make sure that you understand where the numbers are coming from, is important. So this is 3.99 centimeters. So this is the hydrograph. So this here that I have, if I plot these values, this is the hydrograph. Okay, so I would have my hydrograph. Here I have time, and here I have Q. So it would be, this is the direct one, so it already has subtracted the base flow. If I have the base flow, then it will look a little different. So it would be the total. So this would be the base flow, whatever it is. Okay, sorry it's not drawn very nicely, but I hope you get the process. So now I'm going to obtain the unit hydrograph, and this is really, really important, because if you look at the units, they won't make sense to you, because what we've done is now we have the direct runoff, and this direct runoff, and let me erase some of this or use a different pen color. So this here and this here, okay? So this direct runoff produces a total volume of 3.99 centimeters. So this is your hydrograph that you have subtracted the base flow for 3.9. So think of it as a ratio. So if this is the hydrograph for 3.99, what is the hydrograph for 1 centimeter instead of 3.99? Well, what you do is the direct runoff, that's in cubic meters per second, divided by the depth of storm in centimeters. So then this is the unit hydrograph for 1 centimeter. Okay, so if you need to pause, go ahead. And then now this is the work for today. Again, you turn it in 1 per group, so you need to upload in Blackboard both the base flow problem and the unit hydrograph, 1 per group. Thank you.